Hi. Hi. Long time not see much. Guys, that right there on the board is a recap of everything from chapter 5 so far, and it's everything you needed to know on that last quiz. The question then just becomes, okay, now what? Extrema, min-max. Where do they occur? They occur when the derivative is equal to 0, or the derivative doesn't exist, or at an endpoint. That's what you do when you're asked to identify local or absolute minima or maxima. Find the derivative of the function, figure out where it doesn't exist, set it equal to 0, figure out where those points are, and then calculate each of those values. So let's assume that I got x equals c and x equals d, then I've got f of c and I've got f of d, and I've got 4 possibilities. And every one of those 4 possibilities must be some kind of minimum or maximum or inflection point. Because if I start here and I go up and I come down and then I flatten out and I keep going down and then I go down and then I come up, there will be a critical point here, derivative equals 0. There will be a critical point here, derivative equals 0. There will be a critical point here, derivative equals 0, and there's an endpoint and there's an endpoint. I didn't put any examples of...
Good morning, Reardon High School. Please stand for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. It is time to sign up for winter sports. If you are interested in playing basketball, wrestling, or girls bowling, sign up in the office. Girls bowling begins May 3rd. Basketball and wrestling begin May 10th. If you bought school pictures from O'Connor's Photography, they're available in the office for pickup. ASB cards are also available for pickup in the office from Mrs. Googstetter. If you haven't picked yours up yet, do so today. Every student can receive breakfast and lunch at school for free. Grab a free breakfast on your way to class in the morning, and be sure to grab a free hot or cold lunch on your way home each day. If you are leaving school early, this includes running start students and those students that only have one period. Please sign out in the office before you leave. Today is senior presentation day. Good luck to all the seniors.
Those of you planning on staying after school today for some extra support, you do not need to. Teachers will be busy with senior presentations, so there is no after school support today. Thanks.
And for sports, today we have varsity baseball versus Oak Harbor at 4 p.m. And for the joke, how did Benjamin Franklin feel when he discovered electricity? I don't know. Shocked. Have a good day, Meridian.
So one of the things they said reminded me, I love it when my seniors give me a picture of them to put into my stuff. I've got an album of all the seniors who've ever given me pictures. It is not a very thick album. I remember asking Mr. Protzeller how he had so many pictures of seniors. He says, I go around and I grab them by the throat and I shake them until a picture falls out. It's like, oh, okay then. All right, back to this. Guys, this is the big idea here. If you are trying to identify potential extrema, you take the derivative, you set it equal to 0, you figure out where it doesn't exist, you look at the endpoints. Every potential extrema on a continuous function has to fall here, 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 or here. Every one of them. So now the question is minimum, maximum, neither. And we have a couple choices. The second derivative test can help us with that. Because if I have a critical point right there, I've got a positive slope, which switches to a negative slope. My second derivative is going to be less than 0, agreed? My slope is decreasing. So the slope of the slope is negative. Boom. You got some kind of maximum. Critical point. My slope is negative, then my slope is positive. Again, the slope is going from negative to positive, which means that the slope of the slope is positive. It is increasing. The slope is increasing. Boom, I must have a minimum. F double prime does not exist. Okay, well, I can't use second derivative test. I got to figure it out some other way. I've got to look and see what the value of my function was to the left and what the value of my function is to the right. Aha, now I know. Now, here's another way you could do it. You could take f of a of some a value, and you could take f of some b value. Or you could say, well, what's the slope over here? And what's the slope over here? And if it changed, then I must have a minimum or a maximum. So if I'm looking at the graph of f prime, it goes like that. Hey, look, I had a positive slope here. I had a negative slope here. Well, there must be a maximum right there, because I was going up and now I'm going down. Okay. I made notes. Let me see what else I wanted to talk about. Absolute extrema, these are all relatives, agreed? These are all relative. There's minima and maxima littered around the graph. Which one is the absolute? Well, you find out by figuring out what's happening. If I had a graph, this is where you have to just sort of visualize. I'll come back to that word up there. If I have a graph that starts here and has a negative slope, and then a critical point, maybe even just an inflection point, and then more negative slope, and then maybe it has a minimum, and then it stops. Well, of course that has to be an absolute maximum, because it did nothing but go down until like the last little bit. So this is where you just end up analyzing the function. Well, what's it doing? Sometimes you just have to calculate values. Sometimes you just have to plug in A, B, C, and D. You don't necessarily have to actually calculate, but you have to be able to tell which is bigger. A valuable skill is to identify whether a function is positive or negative without actually doing the calculation. One of the examples was that we had a function and the derivative was f prime of x was, if I remember, x squared minus 9 times g of x. And we were told that this was less than 0 all the time. Well, that means that f prime of x is positive when x squared minus 9 is negative, and it's negative when x squared minus 9 is positive. Well, of course I know that. That's a parabola with intersections at -3, 3. Hey, look, it's less than 0 here. It's greater than 0 here and here. Boom, I know when the derivative is negative and derivative is positive without doing anything other than the most basic calculation, which is figure out that x must be plus or minus 3. And because I know the shape of that parabola, I know when that parabola is negative, I know when that parabola is positive. I didn't really have to do much in the way of calculations. Okay? Questions about this stuff? I put a lot of notes on your quizzes this time. I mean, a lot of the time it's just sort of, casual note here or there. I feel like I wrote a lot. If you've got questions about, email me. If you got questions about what I wrote or where you're supposed to go, email me and we can talk. Guys, let's talk about derivatives because I saw a fair amount of fairly horrendous derivative taking. And here's the deal on this. They're getting more complicated. They're getting more complicated intentionally because we should be getting better at taking derivatives, but the basic principles haven't changed. The power rule hasn't changed. The product rule hasn't changed. F of x times g of x. Or, you know what? Let's make it simpler. U times v. You have to be able to know that and do it. And on a regular basis on this quiz, I actually saw people messing up the product rule, which is about as straightforward as it gets when it comes to rules for derivatives. You need to know that one damn cold. Quotient rule. The derivative of u over v. Have to be able to do that one. I actually, oddly enough, saw more mistakes on that than I did on this, which is weird. I think maybe because that was more complicated, we pay more attention when we're doing it, and then we're less likely to make mistakes because we're like, oh, this is the complicated one, and then we pay really close attention, and then the other one we just sort of bang something out, and then it's wrong. The chain rule. The derivative of f of g of x. The derivative of f times the derivative of g. You have to be able to do that. For the most part, guys, those are the rules. And there's little things like, a constant multiplier. What I will say and what I have seen happening, and again, this is just, I think, a function of being in a hurry. Slow down on each step and think about it. I saw people just leaving off constants. If we have 3f of x and then they were taking the derivative and they wrote that. Where'd the 3 go? Well, you just got in a hurry and forgot it. Didn't remember that it was there. Derivatives of basic functions. Which ones do you need to know? You need to know that one. You need to know this one. You need to know that one, and that one. Got the power rule. I'd say one that goes along with the power rule is You need to know that so that when you see this, you rewrite it as that and then use the power rule. I didn't see, I don't know if that came up. I think it came up once. I didn't see a whole lot of mistakes. But guys, this is the stuff you need to know. When I was going back through the quiz, and then in about 30 seconds, I'm going to let you ask questions. When I was going back through the quiz, and I thought, wow, is this quiz really that hard? Was it really that complicated? And as I went through everybody's answers a second time in order to put together my 2 little pages of notes, what I saw was just lots and lots of mistakes where people just did things that made no sense. Not taking the derivative correctly on a product of 2 functions, not taking the derivative correctly on the natural log of a function. And the problem is that once you don't take the derivative correctly, everything else you did is wrong. What I've been trying to do is, as we've gotten a bit more in depth, is I'm trying to grade the way the AP test grades, not because you guys are going to take the AP test, but because it's a useful grading metric. Is that if you, so for example, let's say we were asked to find the extrema, all of them. Well, the first thing they're going to give you a point on is that you found the derivative correctly. The second thing they're going to give you a point on is that you correctly did that. Okay, there's 1 point, and there's 1 point. If you did that wrong, but you did this right, you get 1 out of 2. The third thing that they're going to give you is there a max or a min at various values of x? If you got that wrong, you're not even eligible for this, because you can't possibly calculate the correct extrema if you couldn't find a derivative. So you would get 1 point out of 3 for correctly recognizing that you were looking for those points, and you would lose the 2 points out of 3 because you didn't actually find anything that meant anything to that problem. It's a tough grading because there's an argument to be made that, well, I did that wrong, I lose a point, but now I've correctly calculated all these minima and maxima. But just the problem is, and the reason they grade so harshly, is because these don't make any sense. They're not actually answers to the question. So they give you a point for having a rough idea of what you were supposed to be doing, but they don't give you a whole lot of points for doing the whole thing wrong once you've had that rough idea. So I've been grading a little bit like that, where you'll notice that there's you get, if you're not quite sure how you got points, I haven't been doing a good job of writing on there why I gave you points for this or points for that, but that's just sort of just so you have, know, at least that this is why. Questions? You guys all had a chance to look over your quizzes? Okay. Do you have questions on specific things that you're not quite sure what you did wrong, or when you went back and looked at it with a more relaxed eye, was it pretty obvious that, oh yeah, oh yeah, oh yeah? Because I'm happy to answer those questions now. Nothing? Or is this a thinking?
No. I don't, like, when I went back to that, I could totally understand all of that.
Okay, okay, cool. Okay, quick reminder, because maybe I'm going to be getting far more corrections than I normally get. Usually I get 2 or 3 on most quizzes. I'm assuming I'm going to be getting a lot this time. I want it typed out, including all of your math work. You need to show me the actual solution, and it needs to be typed into a document, not written out and then pictured. The reason is because I want you to get, you guys are all presumably to some extent or another headed for technical careers. You need to know how to use equation editor, which is why I have for years said, you need to type these out and I need to see your work. I want to see step by step how you found that derivative, how you solved for the places where it was zero or did not exist, and how you determined whether each of those places was a minimum or a maximum. I want to see those typed out in your corrections, okay? Be specific. I got a correction the other day, and it basically said, and therefore it must be a maximum, but it didn't tell me how they knew it was a maximum. It didn't show me any calculations. Now, I'm assuming that person did the calculations in their calculator and said, oh, look, it's a maximum, and then wrote, and it's a maximum. You need to show me those calculations. F of 3 equals 5, F of 7 equals 12, therefore this is a maximum, and therefore this is a minimum because there are no other critical points or endpoints on the function, okay? Do those calculations and show me. Here's another one. Oh yeah, watch out for that. I had at least one person on this quiz very carefully explain to me that the limit of x went to infinity was infinity, and the limit as x went to negative infinity was negative infinity, and therefore the function didn't have absolute minima or maxima, except right in the question it said on the interval -2 to 4. And it's like, oh, why? So watch out for those things. Don't get caught out because you just didn't notice that they were giving you a little interval, and you need to think about the endpoints A and B. All right. Questions, things you want me to go through, things you want me to walk through, processes that you'd like to see again? No? Okay. Let me do some then. Since you didn't ask me questions, I may explain stuff you already knew. It's your fault, not mine. These are just things that pop into my head as shortcuts. Because anytime you see a function like this, or the shortcut is that you want to very quickly do an analysis in your head of the functions that are involved in this composite function and say, well, that can never be 0 and it can never be negative, and it's always positive. So the answer to this question is that. If half the function is always positive, then ignore it and say, okay, well, what about the other half? Because if it's going to be 0 or positive or negative, then it 100% depends on this, because that part's always positive. So I can just ignore it. Because trying to calculate when is this equal to 0, well, that's insane. You probably can't do it. Probably nobody can do it. But I don't need to, because that's always a positive number. Boom. That's what I need to figure out. You know what? Forget the equals 0. That's a simple problem based on a shape of graph. The graph looks like that, or looks like that, depending on A. You could do all sorts of complicated calculations, and we did them in algebra and algebra 2. Or you could say it's equal to 0 here and here, And therefore, it must be less than 0 here, greater than 0 here. You don't have to plug in a number to prove that it's negative, because the shape of the parabola requires it to be negative in there. Now, is it a big deal? No, it's not that hard to plug in numbers, unless it's a really complicated function and you got weird numbers, and then you're going to spend 5 minutes calculating these numbers, especially if it's a non-calculated problem, because you're somewhere where you just don't have access to a calculator, you can't have access to a calculator. Or you could just say, well, there's my zeros, and everything in between has to be negative, and everything outside has to be positive. Done. And your justification is the parabola is 0, -3, and 3, and therefore must be less than 0 in between and greater than 0 outside. You don't have to mathematically show a number, because we all know what a quadratic looks like. You just justified it, no calculations at all. Shortcut. Logarithms. You should know all the simplifications for logs. 3, natural log of 2 plus 4, natural log of 8 plus 4. Which is bigger? You should already know. No, they're exactly the same. Because 3 times the natural log of 2 is the natural log of 2 cubed, and 2 cubed is 8. Now, if you didn't think about that, how am I supposed to know that without a calculator? Well, I don't know what they're actually equal to without a calculator. But as soon as I think, hey, look, logarithms, and I know log properties, then I know that they're both the same. But that also tells me which is bigger. Oh, natural log of 8 plus 4 natural log of 8 minus 4, this is a minimum, that's a maximum. Boom, done. Well, what's the natural log of 8? I don't know, and I don't care. Because I know that if I take the same number and add 4 once and subtract 4 twice, one of them is bigger than the other, and now I know where the minimum and where the maximum are. Guys, same thing with all of the log properties. Natural log A plus natural log B is natural log of A times B, if I remember correctly. Natural log of A minus natural log of B is natural log of A divided by B. The power rule, A natural log of X is the same as natural log of X to the A. I think I have those right. Yeah, I'm pretty sure I have them right. Yes, I'm very sure. Yes, I do have them right. I had to think about it for a second there. I think it's only the 3 of them. But again, if you can take a complicated equation and you can just simplify it into something less complicated, you can very easily solve these problems. I saw an interesting question. They were asked to solve some log equation that looked sort of like that. And this was a college test. And it was a complicated enough equation that if you went and typed it in a photo, or stuck it in a photomath, it gave you a 3-page solution, because photomath made some assumptions and gave you this 3-page solution. So what the professor did is he gave him a problem and said, solve for X. And then part B was, here's the photomath solution. Which do you like better? Well, the photomath solution was ridiculous. I would never have occurred to me to do it the way photomath did it, and it was huge. And the whole point of the question was to make the students aware that, hey, we teachers know that photomath exists, and sometimes photomath isn't a good resource because this is crap. Yes, it gives you the right answers after 3 pages of calculation, and it was like a 4-line problem. So anyway, I thought that was interesting, that it's sort of like, hey, don't cheat when you're doing online tests, because we know, and if we see you did that, we'll say, are you insane? All right. Cool. Thanks for coming in, guys. Don't forget, you're more than welcome to come in during G3 if you got math questions. Just because we're not doing calculus right now doesn't mean you can't come in. Have an awesome day. Have awesome presentations if you're seniors. So when school ends at 12:40, go down to the commons, grab a lunch, come back. Oh, yeah, come in. Yeah, get here about 12:40, 12:50. You bet. You betcha. Have a good day.
Have a good one.
Hey, you too, Curtis.
Thank you. Then I'm going.